welcome to the deep dive. You've shared your sources, and, well, you know how this works. We're here to really dig in and pull out the key insights, just for you.
That's the plan. Today, it's all about AI. We're looking at the concepts from that Ai Session.pdf you sent over. Our mission really is to make sense of the big shifts happening.
Exactly. And there's some really fascinating stuff in here. We'll be exploring how AI is changing software development, what these new AI agents are all about, the ones that can think and act.
Yeah, and how the role of AI engineers is evolving too.
Right. Should be some interesting, maybe even surprising moments along the way.
Okay, let's get into it. The material starts with the speaker's background, which is helpful context, I think. 6 years in education startups, journalism background, then 7 years deep in AI research at IIT Madras, IBM research publications.
So definitely someone who's been in the trenches. Sets the stage.
Absolutely. And the first big point they make is this fundamental split between, old school software development and AI development.
The deterministic versus probabilistic thing.
Exactly that. Traditional software is deterministic, like a calculator, right? Same input, same output, every single time. Predictable.
You know what you're getting.
But AI, that runs on probabilistic logic. It's dealing with likelihoods, patterns. So the output isn't always guaranteed to be identical. It's less predictable by nature.
Okay, so that's a huge shift. Moving from guarantees to managing probabilities, that must change how you build things, how you trust them.
It totally does. And it means the old way of judging software, just saying, it works or it doesn't work, that doesn't quite cut it anymore for AI.
Right. So how do we measure success then, if it's not just black and white?
Well, the session gets into specific metrics, both quantitative and qualitative. One big one is relevance of answers.
Relevance.
Yeah.
Like how often users actually find the AI's response useful.
Precisely. What percentage find it relevant? But there's a catch.
Well,
the speaker points out that how specific your ask is, the prompt you give the AI, really affects how well you can measure that relevance. A vague question gets the harder to judge answer.
Makes sense. Garbage in, harder to measure, garbage out, sort of.
Kind of, yeah. Then there's fidelity. That's about how well the model handles the weird stuff, the edge cases.
Edge cases.
Yeah.
Like unusual inputs.
Exactly. Things it doesn't see often. How robust is it when things get a bit strange? That tells you a lot.
Okay. What else?
Consistency. Ask it something similar multiple times. Do you get roughly similar answers? You need that for trust, right?
Yeah, definitely. You don't want it going off the rails unexpectedly.
And the last one mentioned is context utilization. How much better does the AI get if you give it more background, more context in the prompt?
So if I go from a one-line question to a 10-line explanation, does the answer improve significantly?
That's the idea. Does it actually use that extra information effectively?
Okay, so relevance, fidelity, consistency, context utilization. It's a much more nuanced way of looking at performance than just, did it crash?
Exactly. Understanding these metrics is pretty crucial for everything else that follows in the AI space. It's foundational.
Right. Okay, so we've got the software difference. What comes next in the material?
So the discussion then moves to what the speaker calls the AI engineering value chain. Basically, the different ways people contribute to building AI stuff.
A value chain. Like different levels of involvement.
Yeah, 3 main layers are outlined. First is the application development layer. This is using prompts, evaluating outputs, building the actual applications people use.
So this is where you might use an existing AI model to create something new.
Pretty much. And they mention even folks without deep coding skills can play a role here, though that's not the main focus.
Gotcha. Layer 2.
That's the model development layer. This is where you're working directly with the large language models, fine-tuning them, adding specific data. This usually needs more of a research background, apparently.
Right, the deep science bit.
Yeah.
And the third layer.
Infrastructure. This is the nuts and bolts. GPUs, databases, servers, compute power, and also monitoring the AI apps once they're running. Think DevOps, system architecture, folks.
Okay. Application, model, infrastructure. Makes sense. And I mentioned APIs. A lot of companies use those, right? Instead of building models themselves.
Yes, exactly. Many enterprises leverage APIs from the big LLM providers. The speaker gives a simple definition. Think of an API as just a connector.
A connector. Like plumbing between the AI model and the application.
Kind of, yeah. Lets them talk to each other. With a little apology to any engineers listening for the simplification.
Right. And the main point is that all these layers need to work together. Yeah. Application, model, infrastructure.
Absolutely. For a successful AI application, you need all three firing properly. They're interconnected.
Okay, so that framework sets the stage for, well, the really exciting part, I guess, AI agents.
Exactly. This is where the session gets into the idea of agenting AI. AI that doesn't just respond, but can, well, think, plan, and act on its own to achieve goals.
Think, plan, and act. That sounds like a major leap.
It is, but it also brings up the need for boundaries, right?
Boundaries. How so?
Well, if you have an AI acting autonomously, you need to set clear limits on what it can and can't do. Manage the risks. The speaker uses an analogy like a robot having a defined work area it can't leave.
Okay, safety rails for the AI. That's crucial. Is this actually happening now? Are there agents out there?
Oh, yeah. The material gives real examples. There's an AI BDR business development rep called Eva. Apparently, there were billboards in San Francisco.
Billboards?
Yeah.
For an AI?
Yep. Saying, stop hiring humans. Pretty provocative.
Wow, okay. What else?
There's Lyra from Amate.ai, an AI employee for influencer marketing doing outreach, research, engagement.
So AI taking on sales and marketing roles.
Seems like it. And for the tech folks, there's Augment Code, an AI agent to help software engineers working on big, complex code bases.
An AI coding assistant. Which brings up the trust question again, doesn't it? How good are these coding agents? Can you rely on them?
That's the million-dollar question, isn't it? The session tackles this by talking about the SWE bench.
Yes, WE bench, software engineering benchmark.
Exactly. It's a benchmark recognized even by OpenAI that tests if language models can solve real GitHub issues, like debugging actual code, fixing bugs.
Okay, so a proper test, what are the results like?
Pretty impressive, actually. Agents are scoring close to 65% on this. Google's model hit 60.2%. The speaker puts it in perspective. That's like a good junior-level software engineer.
A junior engineer level. Wow, that's significant.
It really is. And think about productivity. The suggestion is a human working with one of these agents could potentially do the work of 4 people.
4 people. So it's about augmentation, not just replacement.
That seems to be the implication, boosting human capability.
Right.
And these agents are getting better, moving past just making mistakes, becoming more reliable.
Which leads nicely to the next point, right? Collaboration.
Yes, the emphasis is really on human-AI collaboration. It's not necessarily about AI taking over, but about humans learning to work with AI effectively. The winners will be those who can partner with these tools.
So companies are looking for people who can use AI. Not just AI experts, but people in any role who can leverage it.
That's the message. Coders and non-coders alike. It's about AI literacy, being able to adopt these tools into your workflow.
Okay. Now, the session apparently included a demo of an agent called MainOS to show this autonomy in action.
Yes, MANS. It's presented as an example of an autonomous AI agent automating tasks. It sounds quite powerful.
What kind of task?
Marketing campaign automation. The goal was to improve customer engagement and ROI. It was given a pretty detailed prompt.
Like what?
Okay, so the goal. Automate and optimize campaigns. Input.raw campaign data. Then specific steps. Segment customers based on demographics, history, behavior, preferences, outputting JSON.
Okay, detailed segmentation.
Then create tailored materials for each segment. Emails, ads, social posts, matching brand guidelines. Analyze performance, open rates, CTR, conversions, ROI. Identify top 3 strengths, weaknesses per segment.
Wow, that's a lot.
There's more. Recommend 3 evidence-based optimizations with expected metrics, especially for struggling segments. And design A/B test plans, variations, metrics, how to interpret results.
So a full marketing strategy and execution plan. Was it given anything else?
Yeah, brand voice guidelines and actual campaign data from an Excel sheet sourced from Kaggle, apparently, so it had real data to work with.
And it just said do it.
Well, here's where the autonomous part comes in. It didn't just follow orders. It asked for clarification first.
It asked questions like what?
Like, should it analyze the whole data set or specific segments? Which specific KPIs were most important? That shows it was thinking, right? Not just executing blindly.
Definitely. So after clarifying,
it built its own plan. Subtasks. Clarify requirements, analyze the data, find patterns, segment the customers, define the messaging, deliver the content, and then it actually wrote and ran Python code itself to do the data analysis.
It wrote and ran code. On its own.
Yep. Calculated ROI by campaign, channel, segment, even installed the Python libraries it needed.
That's really something. What kind of insights did it find?
Things like average and median ROI, identifying the best performing segments and channels, actionable stuff.
And it did the content part too.
It did. Developed a content strategy, defined the brand voice confident, assertive, to the point, and created specific messaging frameworks for each customer segment.
And generated actual marketing copy. Emails, ads.
Exactly. Specific subject lines, email body examples, Facebook ad copy variations, all tailored to the different segments it identified.
It's like a mini marketing agency in a box.
Pretty much. And it didn't stop there. It created the A/B testing plan variations, hypotheses, approach, duration, success metrics.
Wow. And it even made a landing page.
Yeah, a basic web page summarizing everything. The segments, expected ROI boost, the data insights, the content strategy, the A/B plans. It's a very compelling demo of what these agents might do.
Absolutely. Okay, so Amy Laos shows what one powerful agent can do. But then the session talks about Crew AI for making agents work together.
Right. Crew AI is introduced as a framework specifically for building teams of coordinated AI agents.
Teams of agents, how does that work?
There's a hierarchy. You have the crew at the top. Inside the crew are the individual AI agents. Each agent can have tools like search engines or APIs, and there's a process that defines how they collaborate on tasks.
So you can build a virtual team, give them tools, and set them loose on a bigger problem.
That's the idea. You define an agent, its role, goal, backstory, define the task for it. Then you put agents and tasks together in a crew and give it an initial query to kick things off.
Okay, and they showed examples of this too.
Yeah, starting simple. A critical thinker agent.
What did that do?
Just a basic task. Analyze text for conflicting info, respond conflict or no conflict. It worked. It said no conflict for logical text and conflict when they added a fallacy. Just showing the basic setup.
A simple proof of concept. Did they do something more complex?
Yes, an agent with tools, a scriptwriter.
Okay, what was the goal there?
To build an agent that could search the web for the latest info on a topic and then write a conversational script about it. So it needed search tools.
Right, accessing external, up-to-date information.
Exactly. They defined two agents. A content explorer agent to do the research online, find at least 10 relevant pieces of info, and a scriptwriter agent to take that info and craft an interesting conversational script, maybe a bit creative.
And the explorer passes its findings to the writer.
Precisely. The output of the explorer's task becomes the input context for the writer's task. They ran it with the topic, latest use cases of AI in sports.
And what happened?
The Explorer agent autonomously came up with a search query like 2025 AI in sports industry use cases trending views. Found info. Then the scriptwriter generated a script titled The Heated Debate on AI in Sports.
A debate.
Yeah, two characters, a skeptical coach and a tech enthusiast having an angry conversation, supposedly incorporating details found online like AI globalizing La Liga. It even had a slightly British feel to the dialogue, apparently.
Huh. Interesting. So agents collaborating, using tools, generating creative output. That's pretty cool. Was there one more complex example? The stock analysis one?
Yes, the stock analysis crew. But first, the big disclaimer.
Ah, right. Don't use this for actual investing, for educational purposes only, inherent risks, et cetera, et cetera.
Exactly, very important. The goal here was purely to show a complex multi-agent workflow.
Okay, understood. So what did this stock crew do?
It used custom tools built with things like the Yahoo Finance API and search tools, so it could get stock prices, company info, income statements, and general news.
So real financial data access.
Yes. And then they defined 4 agents for the crew.
Okay.
A news info explorer to get the latest company news, a data researcher to pull the financial data like income statements, and data analyst to consolidate all that info and summarize it. And finally, a financial expert agent to make the actual investment recommendation.
News, data, analysis, recommendation, logical steps. And they had dependencies.
Right. The tasks were set up sequentially. Get financials, get news, then analyze using the outputs of the first two, then advise based on the analysis.
So it forces a logical flow. Data first, then analysis, then recommendation.
Exactly. They ran this for a few companies. Reliance Industries was one example, using GPT-4o.
And what did the log show?
It showed the agents executing, data researcher pulling income statements, news researcher finding news, the analyst providing a pretty comprehensive summary, financial health, valuation, risks, prospects.
And the final recommendation.
The financial expert recommended buy, citing strong financials, steady growth, and an apparently undervalued stock price compared to its recent low.
Interesting. Did they run it with a different model too?
Yeah, they reran Reliance with GPT 4.1. The underlying data from Yahoo Finance was the same, of course, but the analysis from the data analyst agent was noted as being more thorough.
And the recommendation?
Still buy, but the reasoning provided by the financial expert agent was apparently more detailed and better articulated with GPT 4.1, shows how the underlying model can impact the quality of the agent's output.
Fascinating comparison. Any other companies?
They tried Zomato, it pulled the current price and recommended no buy.
Why do buy?
High valuation, slim profitability. The suggestion was more like hold or watch.
Okay. And one more, Lodha.
Yeah, they tried Lodha. There was an initial error mentioned, maybe data retrieval issues, but it eventually came back with a buy recommendation.
Okay. So still maybe some bumps in the road, but overall a really powerful demonstration of agents automating a very complex workflow involving data, analysis, and judgment.
Absolutely. It really ties together everything we've discussed, the probabilistic nature, the need for infrastructure, and now these agents that can plan, use tools, and collaborate.
It does. So wrapping this deep dive up, we've seen through menus, through the scriptwriter, the stock analyst. The potential here is pretty immense, isn't it?
Yeah.
Agents that think, plan, and act.
It's definitely more than just a glimpse of the future. It's starting to happen now. These examples show what's possible when AI gets more autonomous.
Which really leaves us with a final thought, doesn't it, for you listening? How could these advancements, this agent capability, start to change your work or the industries you follow?
Yeah, what parts of this are most intriguing? Is it the automation, the analysis, the creative potential? What might you want to explore more yourself?
Because this deep dive, really, it's just scratching the surface. There's a huge landscape of AI out there still to uncover.
Definitely. Stay curious, keep digging. It's a fascinating time to be exploring artificial intelligence. Thanks for joining us on this dive.